This lesson is for FST Lesson 2-1 on functions. A function is a set of ordered pairs where each x is paired with a unique y value. Typically when students see that worded in a question, it'll say, is y a function of x? And the way that I usually handle that question is I usually change the word function to depend. When you're working with a function, there's an independent and a dependent variable, and it's very important that students understand which is which. The independent variable is the one that goes into the machine or into the equation. Something happens to it within the machine or within the equation, and then an output or a dependent variable is spit out. So when the y depends on x, that's telling you that the y is the dependent variable and the x is the independent one. When it's written in function notation, there's usually a name chosen for the function. And so in this case, we've chosen the name f for function, and then the independent variable is highlighted within the parentheses. And when students read this, they should say f of x. Or if it was a g for the function name, then they'd say g of x. And so I've drawn a crude version of a machine here to help students visualize what a function is doing. Also think about it like a pop machine. You plug something in, something happens within the machine, and you get something out. The thing you plug in is the independent variable, the thing you get out is the dependent variable. When working with different types of situations, students need to be able to identify the independent and the dependent variables. In an equation situation, usually the independent variable is the one that has things happening to it. So in this case, the x is being multiplied by 3 and added to 12. The outcome is the dependent variable. Now, if the equation doesn't list x and y as the variables, students can still utilize how it looks to help them figure out which is which. The variable that has things happening to it is usually your independent variable. The one variable that's isolated on the other side of the equation is usually the dependent one. In a coordinate situation, students are used to having x listed first and then y second. And so similarly here, the first thing listed is the independent variable, the second thing listed is the dependent. In a table setup, again, if the variables used are x and y, it's very easy for students to remember that the independent one is the x and the dependent one is the y. If the x and y are not used, students should just pay attention to what's worded in the question. And if there's no other explanation given, they can assume that the top row of the table is the independent and the bottom row is the dependent. In a word problem situation, this is what students can expect to see. The Sudoku Club at EHS needs t-shirts for an upcoming tournament. One store is offering them a deal, buy 2, get 1 free. The cost for one shirt is $10. So what I ask students to usually figure out before they proceed is to determine if C depends on the number of shirts or vice versa. And so what I usually have kids imagine is you go into a store, usually you walk up to the register and you say, I'd like 4 t-shirts. They ring up those t-shirts and then they tell you the cost. So you saying how many t-shirts you want determines the cost or depends on the cost. So if students were to answer this question, does the cost determine the number of shirts or does the cost depend on how many shirts you're going to get? We would say yes. Cost depends on how many shirts you get. So the T comes first and the C is the outcome. T goes into the machine and then C is the result. Typically the way the book will ask that same question is slightly different wording. The book is going to say, is cost, C, a function of the number of shirts? And so you'd think about that the same way that we did the first question. Does C depend on the number of shirts? Just like we would say, is C a function of the number of shirts? So in both cases there we would say yes. Know that the second way is typically how the book is going to ask, or tests and quizzes, how it's going to ask students to figure out which variable is which. Now that we've talked a little bit about independent and dependent variables, typically the next thing we talk about is the domain and the range. The domain and the range are related to the independent and dependent variables. The domain goes with the x or the independent variable, and the range goes with the y or the dependent variable. Typically, when you're writing the domain and the range, you're going to want to use curly brackets, and then you're going to indicate which variable you're using, x or y. And then you use a vertical bar, which means such that, And then within the rest of the curly brackets, there's going to be a lot of different options here for what the domain and the range is going to look like, such that is representative of that vertical bar. So the rest of the domain and the range is going to look like one of these things. Maybe it'll be a range of numbers or a span of numbers. So if you wanted to say that the x's go from 0 to 8, you would indicate it with a double inequality. If you want the domain or the range to just be from one number and then up or down or right or left, you could just use a single inequality. Sometimes your domain or your range is simply a list of specific numbers, and sometimes your domain or your range is a word or a statement, like all real numbers. Keep in mind that all real numbers can also be abbreviated with the symbol for all real numbers, which is a capital R with a double bar. So now that you can see what domain and range are going to look like, let's actually talk about what they are. The domain is a way of you explaining or giving an indication of what types of numbers should go in the independent variable. Same thing with the range. When you give that value, you're saying what kinds of numbers should be plugged in for the range. So in this example that I took from the book, a bakery charges $2 a muffin. Customers get a $2 discount for every 6 muffins that's purchased. So if we were talking about the domain or the range here, let's first figure out which variable is which. Does the cost depend on the number of muffins, or does the number of muffins depend on the cost? And again, if you visualize this here, the muffins determine the cost. So the muffins, M, is your independent variable, and C cost is your dependent variable. So now we're going to use domain and range to describe both of those. So the domain would be representative of what kinds of numbers we could substitute in for M, which is number of muffins. If you think about the number of muffins, you can't really buy a negative muffin or a decimal of a muffin. So we wouldn't want to use all reals as our description of what kinds of values those would be. We'd probably want to talk about numbers like the numbers that we count with, 1, 2, 3, 4, and so on. So the domain here you could say in several different ways. You could say positive integers, because integers include both positive and negative whole numbers. Or you could just simply say the whole numbers. You wouldn't use a decimal or a fraction or a negative to describe the muffins, so you'd only be using numbers like positive integers or whole numbers to describe them. Similarly for the cost, to describe what kinds of numbers we could use for cost, we would use positive. We're not going to owe them money, or the store isn't going to pay you to take their muffins, you have to pay them. So we'd probably say positive real numbers here, because cost could potentially involve decimals. So we want to have some decimals allowed, where we wouldn't have decimals when we deal with the muffins. So the homework's going to have students practice that a little bit further. Domain and range is a review topic from Algebra 1 and Algebra 2, so I think I don't need to go any further with that particular topic. Let's revisit the definition of functions again, a set of ordered pairs where each x is paired with exactly one y. Let's do some table examples for that. And the question here is y a function of x? Another way we could answer that is y depending on x? So if you look here at these different tables, 3 of them already have the answer of yes, and 1 of them is a no. Let's just quickly work through each of those and talk about why. If you think about each of these tables as a machine, you plug 1 in, you get a 1. Plug 2 in, you get a 2. Plug 3 in, you get a 3. Plug 4 in, you get a 4. So what's happening in the machine is not very much. You're plugging in the number and it's spitting it back out. So that is a function. In question B here, you plug in a 1, you get a 2. Plug in a 2, you get a 4. Plug in a 3, you get a 6. Plug in a 4, you get an 8. Each outcome generates a different, or each input generates a different outcome, so that's clearly a function. What gets tricky is when there's repeats involved. Let's look at choice C here. You plug in a 1, you get a 5. You plug in a different x and you get the same result. That is allowed. Repeats in the dependent variable are allowed as long as the x's were independent of each other. For the last example here, we plug in a 1, we get a 4, plug in a 2, you get a 5, plug in a 3, you get a 6. So far so good on that table. It's when we come back and revisit the 2 that we have a problem. You plug in a 2 and it should generate a 5, and in this case it doesn't, so that is no longer considered a function. If you were to change this table so that this 7 was a 5, then it would become a yes. Or if you changed the 2 to something else like a 4, then it would be a yes. But as it sits right now, that particular graph or table is not a function. So repeats in the x value are not allowed when it doesn't generate the proper result. Visually, what just happened is we gave a table version of the vertical line test. Be careful, students, the word vertical is spelled C-A-L, not C-L-E. Make sure you're spelling vertical correctly. You could also just simply abbreviate it as VLT. If a vertical line passes through a graph one time, it is a function. And you can see from these 3 examples here that none of these have repeat x's. All the x's are independent of each other. Some of the y values do repeat, but it's okay if the y values repeat as long as the x's are different. If a vertical line passes through the graph more than once, then it isn't a function, as seen here in all 3 of these examples. On these, you could see that the x value can be repeated and different outcomes are given, so that is not allowed. This is simply a visual representation of what we just did back here in the tables. The last thing that students need to look at is piecewise functions. And piecewise functions just means we're taking several pieces of different functions and putting them together. Students can read more about that on page 82. And I'm going to have students take a look at number 6 and try that one on their own. And I'm going to scroll through the rest of the video here to provide students with the answer to number 6. They can get assistance during class if they need it.